Alright everybody, here goes a video on how you graph rational function hyperbolas. And these are just going to be starting out with the easy basic ones, and then the next couple of videos will take it up a notch. So to start, we just need to talk about what a rational function is. Well, a rational function is basically when you divide two functions. So the first, most easiest one we want to talk about is y is equal to 1 over x. Just so you kind of get an idea of what's happening. So what value of x is not allowed? So if you know anything about dividing, you know that you are never allowed to divide by 0. So 0 is not allowed. So what values of y are impossible? For this situation, 0 is also impossible. And here's why. What if you were to divide 1 by 1? You get 1. If you divided 1 by 2, you get 1/2. If you divided 1 by 4, you'd get 1/4. If you divided 1 by 1,000,000, you would have 1/1,000,000th. Although it's very, very small, it does not ever get you to 0. And if you were to divide by fractions, so 1 divided by 1/2 is 2. 1 divided by 1/4 is 4. 1 divided by 1/100th is 100. So you're never going to get to a y value of 0. If we were to sketch that out, we would have 1, 1. 2 would give us 1/2. 4 would give us 1/4. If we went backwards to 1/2, that would bring us up to 2. If we went to 1/4, that would bring us all the way up to 4. So what you're going to see is a graph that looks a little bit like this. But then if you were to go do that with negatives, so if you were to do -1, you would divide and have a -1. If you did -2, it would be -1/2. If you did -4, it would be -1/4. -1/2 would be a -2. So what you see is this funny little shape that never touches the x-axis or the y-axis, because this is known as a hyperbola. And these blue things are called branches. And they never hit these impossible values. Now, on a graph, those impossible values are called asymptotes. An asymptote is a line that represents impossible values. Okay, so we have two of them. Those are asymptotes. And an asymptote, like I said, it represents part of a graph that a function will never equal. So that was the most basic, just to introduce you to the types of graphs you're going to see. Now you have two different forms that we're going to be working with. One where we have a number over a binomial, and then we're going to have a plus k off to the side. That means x is your vertical asymptote. Your vertical asymptote is going to be what makes the denominator 0. And your horizontal asymptote is this number off to the side. Now, if you have two functions divided, then your vertical asymptote will still be what makes your denominator 0. So that's going to be the nice thing about every rational function you graph, is you just set the denominator equal to 0 to find your vertical asymptote. But when you have two functions, you just have to take the fraction of your leading coefficients. So let's check it out. Here's one in the first form. So in the first form, the vertical asymptote is what makes your denominator 0. So all you have to do is take your denominator and set it equal to 0. So x minus 3 equals 0, so x equals 3. That is your vertical asymptote. So we're going to go to x equals 3, and we're just going to sketch the vertical asymptote. Your horizontal asymptote, when it's in this form, it's y equals this number off to the side. So y is equal to a -4. So we're just going to do a dashed horizontal line. So you always want your asymptotes to be dashed. They are not officially part of this graph. Now, domain. The domain is all real numbers except x is not allowed to equal 3. Again, if we have a 3, 3 minus 3 is 0, you can never divide by a 0. So the domain is basically x cannot equal your vertical asymptote. Your range is the same thing. So range is all real numbers except for y is never going to equal the -4, because we can never have that part either, because that is an asymptote. So now, to sketch the graph, to be honest, all you need to do is go use your graphing calculator. But the tricky part is how do you type it in? If you have a calculator that does nice, pretty print, it's pretty easy to do. But if you have an older calculator, you have to think of it in terms of here's a fraction, here's a group, here's a number off to the side. So if you have one of those straight line calculators, in Y1, you want to type the fraction. Inside the fraction, you'd have your numerator divided by your denominator, each one of those in their own set of parentheses, and then the -4 goes outside of the parentheses. So you have one set of parentheses for your fraction, a set for your numerator, and a set for your denominator. So that's for the old school calculators. If you have one that is much nicer for pretty print fractions, it'll be easier for you to type. Okay, but then all you really need to do is type that into your graphing calculator and then use either a table or you can just sketch the graph. Just go find some nice pretty numbers and just go see what you get. Type it in the graphing calculator and just sketch it out. So this one's going to look a little something like this. And then if you were to go to the other side of your asymptote, you'd have like a 2, -6, and you would have a 1, -5, and just give yourself a little swoop. Okay, so that's how you graph a rational function. Just make sure you type it into your graphing calculator, plot down a couple of pretty points, and just sketch it. I'm not looking for perfection. Okay? In the other form, as I mentioned, the vertical asymptote is always going to be what you get when you set the denominator equal to 0. So we have 2x minus 4, so 2x is equal to 4, so x is equal to 2. Your vertical asymptote is x is equal to 2. Which means your range is all real numbers except x cannot equal 2. And you would just go to x equals 2. You would sketch your asymptote. That's the most important part for me, is that you know how to sketch your asymptotes. Then what you're going to need to do is go list your y equals horizontal asymptote. Now this is different. This is where you take your leading coefficients, so you have 1x over 2x, and you reduce it so it's y is equal to 1/2, which means your range is all real numbers except for y is not allowed to equal 1/2. So you would just sketch a horizontal line where y is equal to 1/2. And then you have it all set up. So then you need to go to your graphing calculator, and you would type y is equal to, now if it's just a standalone fraction, you can do your numerator divided by your denominator. But yes, if you wanted to, you could wrap the entire thing in its own set of parentheses as well. Really, that part is up to you. When it's a fraction, you can just do top in parentheses divided by the bottom in parentheses. But if you do the extra work, it's not going to change your answer at all. So after you do that, you just have to type it in the graphing calculator, press graph, and just sketch it. And again, you would want to just get some pretty points, but for the purpose of this example, the asymptotes are the most important part. The graph, I'm just going to allow you to use your graphing calculator, so you never have to worry about trying to graph one of those out by hand. I mean, I could if I wanted to be evil, but then you would just calculate some nice points by hand instead by using a XY column chart, but it's not going to happen. So if you know how to type it in the graphing calculator and press graph, all I need is a little sketch. I am going to be very harsh on the fact that you have the correct vertical and horizontal asymptotes, but the little branches, I don't expect them to be perfect. All right, that's it for this video. This is Longo and I'm out. See you, bye.